There is a newly developed fertilizer, Fertilizer K, for growing watermelons. We would like to compare the performance of this new fertilizer against the most popular Fertilizer A. The experimental farmland has an area of 500 meters by 500 meters. There is a small stream running from the east to the west on the south edge of this farmland, and the farmland is high in the east with an inclination of 5 in 100. Therefore, the farmland is wettest in the south and of highest altitude in the east. Since the altitude of the land and the soil water contents are not even across the farmland, and these factors are likely to influence the growth of watermelons, we divide the farmland into 9 regions to minimize the effects of such variations. Each region will be a square of 130 meters length. 25 meters wide aisles will be left to separate each region. The margin in the south will be 35 meters to prevent fertilizers from being washed away by the stream. Within each region, 18 quadrants for A and 18 quadrants for K are alternately placed to minimize the effects of natural variation and explainable variation. Each quadrant is 20 meters by 20 meters large. Enough space is spared for margins between each quadrant to avoid fertilizers from being transferred to neighboring quadrants. Now, let's take a closer look at one of the quadrats using Fertilizer K. All watermelons in it are growing with Fertilizer K only. Each quadrant has 10 rows, and each row has 10 watermelons with separations of 2 meters apart. Each row is also 2 meters apart, with sprinklers in between. Irrigation frequency and water flow are kept constant throughout the study. So to summarize the setup, there are 9 regions in the farmland, each region containing 18 quadrats of A and K each, and in each quadrant we have 100 watermelons. We randomly sample 10% of them for measurement. Only fully mature and healthy watermelons will be measured. To harvest our samples, we need a random table to pick a random date in October. Moreover, to ensure watermelons grown in all levels of soil condition are obtained for the study, random samples of the same size will be drawn from each of the 9 regions. Suppose the optimal sample size suggested by our pilot test is 15A and 15K from each of the 9 regions. Then, from each region, we will randomly pick 15 quadrant A's and 15 quadrant K's. For each quadrant picked, we will randomly draw 10 watermelons for the measurements, and the mean for the 10 watermelons will be considered. The mean values for the 15 quadrant A's and 15 quadrant K's will be used to find the mean of the mean for the 2 fertilizers in that particular region. In this way, the mean for watermelons grown with A and the mean for those grown with K will be found for all the 9 regions, and hypothesis testing will be conducted for each region, and also the average of all of the 9 regions.